Hey everybody! So you guys have just finished learning how to multiply and divide rational expressions. Now we are going to add and subtract them, okay? So before we get started into that, I first just want to go over least common denominators and how to find those, okay? So first we're just going to be looking at the denominators because that's what we're trying to find is the least common denominator. So let's go ahead and find what those denominators are. This is just x minus 3, so that's cool. This x squared minus 6x plus 9, I'm going to need to factor that. So that would be x and x. Let's see. Factors of 9 are 3 and 3. To get negative 6, it looks like they both need to be minus. Okay. Another way to write that would be x minus 3 squared because it happens twice. It's the same factor twice. Over here, this would be x, let's see, 10 and 3. And positive 10 minus 3. Now here, if you wrote x plus 10 and then times x minus 3, that's the same thing, okay? Alrighty, so the least common denominator, we are going to take every factor that appears to the highest degree that's present in the originals. So I have an x minus 3, and I have an x minus 3 here, and another x minus 3. This has a degree of 1 because it only shows up one time. This has a degree of 1 because it only shows up one time in this term. But it shows up twice here. That has a degree of 2. So part of my least common denominator will be x minus 3 squared, or you could just write it out twice, okay? And so that takes care of that term. Over here, I have an x plus 10, and that only occurs in that one, and it just occurs one time, so it's going to look like that. Okay, so look at all your denominators, and those should all appear down here, but just take the highest degree of what appears, okay? All right, number 2, let's see here. This is a difference of 2 squares, so this is x plus 3 times x minus 3. And then over here, we've got, it looks like x plus 3 times x plus 3. And again, because it's the same factor, I can just write that as x plus 3 squared. So either or. So I have an x plus 3 in both of these, but again, this is the highest degree, so this is going to be x plus 3 squared. And then I also have an x minus 3 in this one, so that's going to be part of the least common denominator as well. Okay, and it should get all taken care of, like all these denominators should be taken care of down here. All right, number 3. So I can take a GCF out of 9 here, so x plus 1. And then over here, this is just 6x. Nothing changes there. Now, we have this 9 and this 6. It's the number out in front of the x's, right? The coefficients. We didn't have that in problems number 1 and 2. But down here, we're going to have to look at their multiples, okay? We want to find the least common multiple of these numbers. So multiples of 6 are 6, 12, 18, 24, and so on. Multiples of 9 are 9, 18, 27, and so on. Notice 18 occurs twice, or like it occurs once in each list, right? It occurs in each list. So that is the least common multiple. So that's going to be part of the least common denominator. We're going to have an 18. That will take care of the 9 and the 6. Now I also have this x plus 1 and this x. So this is a factor and this is also a factor. So that would be our least common multiple. Be careful. You're not just going to say like, oh, if I add 1 right here, it's the same thing. No, okay, because if you said plus 1 right there, then you would have to, 6x plus 1 is completely different than 6 times x plus 1. So just don't become a magician right there, okay? We're mathematicians. Just copy down your factors that you already have. All right, number 4. So we've got 2. X squared is like an x times x, if you want to think of it like that. And then over here we have a 3x. So let's look at the numbers. Let's find the least common multiples of 2 and 3. So we've got 2, 4, 6, 8, and so on. For 3, we've got 3, 6, 9, and so on. So it looks like the least common multiple is going to be 6 because it occurs It's the smallest number that occurs in both lists. Okay, so the smallest number in both lists. And then I have 2 x's here and only 1 x here. This has the higher degree because there's 2 of them, so this will be 6 squared. Okay, so that's how you find least common denominator. Alrighty, now we're actually going to get into steps to add or subtract the rational expressions. So we've got these steps written here for you. Okay, first we're going to factor the denominator. So I'm just going to kind of like walk through these steps as I do this problem so you guys can see how it's used. Okay, so x squared minus 4, that's a difference of 2 squares. So x plus 2 times x minus 2. Over here, this would be x plus 2 times x plus 2. So I factored both denominators out. Remember, you could write this as x plus 2 squared if you want, okay? Because it's the same factor twice. So I factored the denominators. Check. All right, now I'm going to determine the least common denominator. Put 1 right there. This was step 1. All right, so the least common denominator would be, I have an x plus 2 and an x plus 2 here. This has the higher degree though, so it's going to be x plus 2 squared. And then I also have this x minus 2 that I need to include, and that only occurs once. So there's my least common denominator. All right, step 3, I'm going to find the restrictions of the least common denominator. That means, the reason why we're doing that is because the denominator of a fraction can't be 0. Because if you have something over 0, you're going to get an error. Like for an example, if I did like 5 divided by 0, can't divide by 0. A divided by 0. Error divide by 0. Negative 1 divided by 0. Okay, you get an error every time. So we need to figure out what x values would make that denominator equal to 0. So to do that, you're going to set each factor equal to 0. Kind of like we would when we were solving equations. Now, you only have to write this one time, even though it occurs twice, because whoops, that's all I wanted to do. Even though it occurs twice, because it will be accounted for already by doing it one time. So you don't really need the parentheses, sorry. And you're going to solve for x. So to move this 2 to the other side, I'm going to subtract 2. So x will be negative 2. And over here, x would be 2. And that's what x cannot equal. So x can't equal these. Those are the restrictions. So if I get x equals 2, it's going to make this denominator equal to 0. Or if I get x equals negative 2, that's going to make the denominator equal to 0. So those are our restrictions. And then step 4 is convert all fractions to having the least common denominator. So in this one, we have, do you guys see how, let me get another color, hold on. Oh, let's get some funness in here. Let's do orange. Okay. So the least common denominator, so you want to multiply everything, or each term by the least common denominator. So I'll be multiplying this guy by x plus 2 squared times x minus 2. And this term by that, x plus 2 squared, x minus 2. And the reason why we do that is because these will cancel. So then I'm just left, oh, I probably should have done it over here first. I'm sorry. So this will cancel with that. Only one of them will go out. And this x minus 2 will cancel with this. So really what I'm left with right here is 2 times x plus 2, because we got rid of the other x plus 2 from canceling it out, plus x times x minus 2 all over the denominator of the least common denominator. Because once these have the same denominators, you guys are good to go. All right. Oh, sorry, I need to move this down a little bit. All right, so then step 5 is you're going to add and subtract those terms. So this becomes 2x plus 4 plus, whoops, x squared minus 2x all over sorry, all over x plus 2 squared times x minus 2. And then step 6 is just to simplify it. So let's combine our like terms. We've got an x squared. Let's see here. Those cancel, right? So plus 4 all over x plus 2 squared, x minus 2. Whew, that was a lot. And you guys cannot factor out this x squared plus 4. Even though these are squares, it's not a difference because that's a plus sign. Difference of squares would be a minus sign right there. So that's it. So the main things that you guys need to have in your answer is what it looks like simplified and the restrictions of your domain there. Okay, number 2. So let's figure out what these denominators are. So this would be, it looks like a 4 and a 1, negative 4 plus 1. And this would be x plus 1 times x minus 1. Because it's a difference of squares. See how that's a minus sign? This was not a minus sign. That's why you can't factor that. So our least common denominator would be, it looks like we have an x plus 1 in both of these. This one has a x minus 4. And this one has an x minus 1. So now we've accounted for everything. So x cannot equal negative 1, because when I set that equal to 0, I'm going to get negative 1. It also cannot equal 4, because when I set that equal to 0 and add 4, when I set this equal to 0 and add 1, I get 1. So x cannot equal these numbers. That's part of our answer. All right, and then it looks like this denominator, oh, guys, I'm sorry. I shouldn't have crossed that out over there. That was bad. I need to multiply both this numerator and denominator. It already has the x plus 1 and the x minus 4. I just need the x minus 1 over here. So now I have that in the numerator and denominator. That's what's happening there. This was very bad math notation. But whatever you multiply the numerator by, you want to multiply the denominator by 2, because this is really, that divided by that is 1, so that doesn't change the problem. This is going to bother me. I need to fix this. Sorry. So this was missing an x plus 2. Okay, that's much better. All right, so you guys see how these are all 3 terms are in the denominator now there. So then I have, I'm going to go ahead and distribute that there. So 2x minus 2 and I like to change this into a plus and distribute that negative over. You don't have to do that. Plus, and then this becomes, I have an x plus 1, x minus 1. I need the x minus 4. So this becomes negative 1x plus 4. That's a way for me not to like forget about that negative sign, so that's why I do it like that. All over, and now that these have the same denominators, that's why I'm able to combine the numerators together. And then we simplify. So it looks like 2x minus x is just x. Negative 2 plus 4 is positive 2. And that's it. You guys can't simplify that. There's no x plus 2 factor. So that's it. Okay, let's flip it over. We got 2 more problems. Okay. All right, here, let's factor out this denominator. Ooh, we can't factor that. And we can't factor that. So let's talk about what the least common denominator is. That would have to be, we have this 5x minus 1 term, and we have this 6. So that's your least common denominator. So in order to add these, I need to multiply this part of the fraction by 6, and this one by 5x minus 1, so now they both have the same denominators. That's why I was trying to show you guys over here. on number 1, I just didn't do a very good job of showing that. I apologize. Just, yeah, my bad. Look at how I did number 2 and the problems after. So, now that these have the same denominators, you guys see that? Yeah. Now I can combine their numerators. So 6 times 6 is 36, plus, because it's a plus sign, 5 times 5x is 25x. 5 times -1 is -5, all over this guy, the denominator. Let's see. So I get 25x. What's 36 minus 5? 31. All over 6 times 5x minus 1. And I can't factor anything out of the 25 and the 31, so that's it. Yeah, just making sure here. Yeah, there's nothing I can do. So that's your answer. We need to find the restrictions, though, because remember, it says you have to find the least common denominator, find the restrictions. So let me actually go back here. So the denominator was, the least common denominator was 5x minus 1 equals 0 and 6 equals 0. Well, we don't need to worry about the 6 because that statement's not true. So to find what x can't equal, I'm going to add 1 to both sides. Whoops, plus 1. So 5x equals 1, and then I'm going to divide both sides by 5. So x cannot equal 1/5, and I'll show you why. So if I do 25 times 1/5 plus 31, I get 36 in the numerator. And then if I do 6 times 5 times 1/5, so now I'm plugging in the 1/5 in the denominator. Whoops, hit a button. I get 0, so then I get 36 divided by 0, which is an error. So that's why that does not work. Okay? All right, last problem. This is subtraction. I'm going to change it to an addition problem. So I'm going to make this plus, make this minus, make that plus. So that way I don't forget about the negative and distributing it to every term. So this becomes x and x. Let's see here. That will be 7 and 4. -7 plus 4? Yeah. This will be x, let's see, 7 and 5, wait, 7 minus 5? Oh, wow, it's a crazy one. Did I do that right? Sorry, I'm just checking myself real quick. Okay, this one's a little weird. So if you didn't want to distribute that negative first, you would notice that you have an x minus 5 in the numerator and the denominator, but I don't want to trip us up. So, well, that simplifies. Let me see something real quick, sorry. Okay, yeah, we actually want to keep it like that. Okay, so from here, our least common denominator, I have an x plus 4, I have an x minus 7, I have an x minus 5, and an x plus 7. So there's a lot there. So I'm going to need to multiply this part basically by that whole denominator, because I already have the x plus 4 and the x minus 7. So I'm just going to rewrite that. And then over here, I'm just going to rewrite this guy because it's missing the x plus 4, x minus 7. Alrighty. So let's see. X cannot equal -4. It can't equal 7. It can't equal 5. And it can't equal -7 when I set those all equal to 0. That's a lot of restrictions. So let's go ahead and FOIL this. So this becomes x to the 3rd plus 2x squared minus 35x. Now I got to do the same thing to the 4. Plus 4x squared plus 8x. 4 times 35. And that's a minus sign, so negative 140. Plus, this is wild, sorry, negative x to the third, positive 3x, positive 28x. And these should actually be squared. That should be 3x squared right there. Positive 3x squared minus 28. Wait, 2 negatives make a positive. Yeah, 28x. Whew. Okay. All right, now the 5. 5x squared minus 15x. What's 5 times 28? Whoops. 5x squared, negative 15x, negative 140. Okay, all of that over x plus 4, x minus 7, x minus 5, x plus 7. Okay, I will not give you something this crazy. Sorry, guys. So let's see here. We've got x to the third minus x to the third, so that cancels. We've got an x squared, x squared, x squared, x squared. So 2 plus 4 is 6, plus 3 is 9, plus 5 is 14x squared. All right, I'm going to do a different color. Negative 35x, 8x, 28x, 15x. So negative 35 plus 8 plus 28 minus 15. Negative 14x. And negative 140 minus 140, sorry, is negative 280 all over this. Alrighty. And then the very last thing we're going to do is factor that out. Is 280 divided by 14? Can we do that? Yes, we can. So I'm going to factor out 14 out of that numerator. So I get x squared minus, actually, I'm going to do this to the side over here. So 14, you get x squared minus x minus 20. And I can factor that further. So this is 14x plus 4, x minus 5 when I factor that. Okay? So I'm going to rewrite this in place for that. So this will be 14x plus 4 times x minus 5 all over x plus 4, x minus 7, x minus 5, x plus 7. And notice that it cancels and that cancels. So you get 14 over x minus 7 times x plus 7. That is your final answer. All of that comes down to this. Now, all of these are your restrictions though, because depending on like whatever your x value equals, when you plug it back into the original problem, if you guys plug any of these numbers, even the negative 4 and the 5, back into this original problem, the denominator is 0 or equals 0, which makes the function undefined there. So even though the x plus 4 and the x minus 5 aren't in this denominator, it still affects the restrictions. So to find like the restrictions of your denominator, just look at the least common denominator that you get from the beginning. Okay? All right, if you guys have any questions, please, please, please ask. This can get a little tricky. Okay? All right, see ya.